Okay, so let's go through the proof of the corollary here, corollary 1. So I'm going to read this and explain it as I go. Okay, so it says, prove first, a homogeneous system with at least one non-zero solution, vector v, has infinitely many solutions. Because why? Why? Because you can basically multiply v, vector v, by any scalar. Right, so we can look at all the different scalar multiples of v, or non-zero rather, right? So well, it really doesn't matter if it's a scalar, zero, so zero will work just fine too. So we take all the scalar multiples, well that vector is also going to be a solution to the homogeneous system, right? Because we've seen that before, okay? Now, that means that there's going to be there are infinitely many vectors then, right? Oh, and we're talking about, right, non-zero vectors, right? So if we talk about any non-zero vectors v, and we can multiply, take all the infinitely many scalars, then that means our solution set for this homogeneous system is going to be infinite, okay? And so if, for example, if we take two real numbers, two scalars, s and t, are unequal, then we can also know that this vector is not going to be the same as that vector, right? And the reason why is from before, right? So we could say, okay, well, s times vector v minus t times vector v is just going to equal s minus t, quantity, times vector v, right? And so if these are non-zero scalars, right, so this is going to be non-zero, right? So we can keep coming up with an infinite number of scalars, right? So now, if we apply lemma 1 to this, then what it's going to show us is that either we're just going to have no solution, right? Zero solution because we have no particular value vector p as a solution, right? So that means we're either going to have a zero, or excuse me, no solutions, right? Or we're going to have one particular solution because there'll be a p, right? There'll be a particular p vector, but not a unique homogeneous solution. We'll just have the zero vector. So that means we'll just have one solution, or we're just going to have an infinitely many solutions, like in the case where we just looked at, okay? Well, where we have a non-zero vector and one of these infinitely many non-zero solutions. And that's the end of the proof, right? So that means that because of this, so this is the infinitely many non-zero solutions of the homogeneous system. That's what this actually shows. You have to have an infinitely many. Once we do this, then we just apply lemma 1, which says basically you're either going to have only one, right? Because it has to fit. If you have one particular solution, right, you can either have the zero vector, so which means that there's zero solutions, or you'll have a particular solution p vector, and the trivial case of the homogeneous system, which is the zero vector, or you'll have a situation where you have infinitely many non-zero solutions. And that's it. Have a great day.